I will hand it off to our next speaker here.
Hi, everyone. Share my screen. All right, so I am going to talk a little bit about the role of REU sites in promoting diversity. And to do this, I recruited a couple other kind of guest speakers to help me out. So I am Dan Minner. I run help run one of the REU sites at IUPUI, and we do a lot of other kind of research-based outreach as well. So I'll talk a little bit about what REU sites are. I'm not really going to use this as an advertisement for ours, so kind of just general kind of concepts that most of them follow. And then I'm going to pull in Mark Wilhelm, who is a graduate student here that has been kind of an active mentor in these programs. He can kind of talk about the benefits and impacts he's seen from student participants. And then at the close, we will pull in Paula, who is another graduate student here. But she actually started out as a past participant in this program. So she can tell you a little bit about, what she's been doing and how the program has kind of set her up for success. So we'll start by what is an REU program. And this is going to be a little bit backwards from the other presentations. So this is going to be a little more early on in your undergraduate career. Although we do recruit some senior level students sometimes. But the goal of most REU programs is to really get undergraduates interested in research and give them experience and kind of the skills they need to really ease their transition into future graduate programming. So regardless of what REU site you would apply to, and there are many, they all kind of follow the same general idea that they normally recruit a cohort of 10 students per year. And they would come to the university and conduct 10 weeks of research in the summer. And each REU site kind of has a designated central theme or focus area. Now, one thing that's important, because I know this is primarily a chemistry conference right now, but don't limit yourself to just, sites that are within departments of chemistry. Everything is so multidisciplinary now. So for example, you may have a central theme like ours on nanomaterials, but we have chemists working in engineering labs. I have engineering students working in chemistry labs, right? So a lot of these type of multidisciplinary areas require a lot of disciplines to come together to actually make something happen. You may also find other sites, for example, I don't know, maybe there's a site on, water quality or something like that, where they have some sort of central project where maybe they're using, chemists to analyze one component, and then a team of engineers is collaborating to design like some sort of testing, with the information they're all producing. So most of these sites, while you may see them in one department, they normally have some sort of multidisciplinary context to them. But in general, regardless of what the theme is, they all kind of have these kind of central activities that they provide. So the biggest kind of one is providing these individual academic research experiences. So for students that have just done lab work up until now, this is different. This is not coursework. This is not doing, different pre-planned cookie cutter experiments on a daily basis. This is kind of full immersion into a research lab as an independent researcher, working with graduate student colleagues around you, participating in weekly research meetings with the faculty, doing all of this. You are treated as a full graduate student, more or less. And normally that's about 80% of what a REU is. The other 20% is kind of filled with professional development programming to, like I say, kind of ease this, transition into future graduate work. So, and we'll talk a little bit more about what that is, but it's things like developing communication skills through student seminars, how to find graduate programs and apply to them. We also have a resume building thing as well, stuff like of that nature. And then kind of the goal with these is you come and you work 40 hours a week. This is your job. You are a researcher doing these programs. So we provide housing, we provide travel costs, we provide a stipend so that you can come and live and survive and all that stuff, and really treat this as your full-time job. And then while the bulk of these activities all happen during the summer, almost any REU site is going to also provide some form of post-program mentoring and other things like that nature. This could be kind of long-term relationships with mentors. We've had a lot of students come back. Maybe you want to go to a conference later on. You know, a lot of REUs would have money set aside for that, or during the academic year, they can still support travel and things like that. So it's kind of really hoping to give a student this well-rounded experience that kind of gives them the motivation and confidence to kind of continue to pursue academic research. So our site is focused on nanomaterials. Nanomaterials are both energy and biological applications. So that's a pretty broad context, but we have the advantage that we have this big medical school on campus. So we kind of have engineers working on energy, and then we have, you know, other groups in kind of the medical school that are taking a lot of these nanomaterials developments and using them for other things like sensors and things like that nature. So yeah, so we have this kind of big multidisciplinary thing, and why you notice that a lot of these sites have this multidisciplinary context is two reasons really. Like, it really allows us to attract students from varying STEM disciplines. Like I said, we recruit engineers, we recruit pre-med students, we recruit chemists, physics, all those people, and we can normally find a home for them within this realm of nanomaterials. The other thing is just so much of science now is so collaborative in nature. I mean, even 10 years ago when I was getting my PhD, you know, it was from a chemistry department, but I was doing very little chemistry. I was really doing more like biophysics and cell biology. So, I mean, everything is becoming so multidisciplinary, and we kind of like to foster that early on, like students' abilities to think, you know, across disciplines and communicate effectively with people with other areas of, you know, backgrounds and expertise. So this is an example of our kind of mentors and types of projects that we do. So like I said, because we're this kind of multidisciplinary topic of nanomaterials, we have researchers from science, engineering, medicine. We've even had a couple from the School of Dentistry before. And you can see project titles really kind of span on how we're using these nanomaterials. So it's all, they sound like broad projects, but it's all kind of focused on the creation of these new nanomaterials and how to apply them to different things. So most of our projects, like I said, with respect to energy, we have batteries, we have graphene, we have carbon nanotubes. And then with respect to bio, we have people that are using, you know, a certain nanoparticle for a sensing application, or maybe like a drug carrier, things of that nature. So if we look here, these are kind of these central goals of most REU sites. So like I said, you can find an REU site in almost any area, but right, they're all funded by the same NSF program. So they're all following the same NSF solicitation. They all have very similar goals. Really, the central goal in almost any REU program is increasing diversity in STEM. So it wants to see pretty ambitious goals for student cohorts in terms of diversity. The other thing is, like I mentioned, just promoting undergraduate involvement in academic research in general. Another thing I'll talk about in a little more detail on these upcoming slides is not only recruiting, you know, diversity with respect to ethnicity and you know, gender, things like that, but also diversity with respect to kind of where students are coming from. So there's also an emphasis on, you know, recruiting students who maybe from, you know, community colleges or technical colleges, or maybe undergraduate only colleges that maybe don't have that, you know, firsthand experience where they get to see graduate students and what graduate school really is. So we also have a lot of diversity in kind of the type of institute students are coming from. But really, like I said, the goal with all of this is to really build research experience and understanding of what research is, working side by side with grad students and understanding really what life as a graduate student is. This is something you're interested in, you know? And then kind of just throughout the summer with multiple presentations and poster sessions, developing key skills that are gonna not only help you in graduate school, but really just careers in STEM in general. Things like how to, give a science talk, how to, present data effectively, things like that. And then the other thing we do is we will have seminars, for example, from anywhere from industry professionals to academia people to really show you career pathways and options, what you can do in STEM. So with respect to recruitment, like I said, pretty much any REU is going to have some recruitment goal in the terms of underrepresented minorities in STEM. Normally, this has to do with race, ethnicity, and gender. So these are groups that we typically see less often in graduate school programs. And the goal of most REUs is to kind of increase these numbers as we go on. I also mentioned the inclusion of first-generation college students as well. So again, kind of increasing diversity, and we like to grab students that maybe don't have graduate school in their career plan, maybe students that aren't even familiar with what graduate school is. And then I also mentioned, and then really focusing on, if possible, providing opportunities for students from schools that don't currently have these opportunities. So these could be community colleges and liberal arts schools that maybe just don't have a strong, science staple or engineering staple at their schools, or maybe have graduate school in, certain areas like, more social study type areas and less graduate programming and engineering and science. Things like that. Things where students at these schools may just be unaware of these opportunities and what they really mean. All right, and the other thing we do is, I mentioned, we kind of hopefully create this platform for kind of post-program mentoring as well. So we're hoping that students really kind of build lasting relationships with the mentors that they had in the lab. They really provide kind of post-program mentoring, throughout graduate program and into their careers. So we really make an effort at making sure that the collection of mentors also kind of mirrors the diversity of the student cohort as well. Because I think this is advantageous. If you are a woman in science, we can pair you with a woman in science mentor that can help you kind of transition through all of this. So this just kind of shows a little bit of diversity data from our REU site. Our REU site's going on 5 years now. So this kind of shows a little bit of the breakdown in kind of what we strive for in diversity. The other thing, though, that I wanted to highlight from this is also this orange box, this kind of educational level box. So if you look a lot, our goal is not necessarily to recruit senior students. We do recruit senior students, but our goal more than anything is to kind of recruit students younger, to kind of really give them kind of an experience early on so that they really kind of understand what research is. I know when I first started graduate school, there was this talk in the first session about how many hours you need to spend to prepare yourself, things like that. I will say that I felt very underprepared when I started graduate school. And when I was working with my peers that were third-year students, I just almost felt like I wasn't good enough. Like, why am I here? And a lot of that was, again, just that confidence in not realizing how research works and realizing the huge amount of failure that goes along with research and problems that you kind of fix continuously. I feel like instilling that mentality early on really helps kind of build confidence in students that they can do this and all these things are normal. And really kind of promotes, maybe they get involved in this research program and then the following year, hopefully they find other things to kind of continue to kind of peak and build their interest as they, like I said, the ultimate goal is that, we develop this mindset where they love research, hopefully, and they want to kind of transition into these graduate programs. So, like I said, in terms of professional development and what these programs normally kind of do, really with any REU program, the bulk of everything is going to be in the lab, research experience, hands-on. That can be wet lab research, that can be computational, but more than anything, you're going to probably commit at least 80% of your kind of 40-hour weeks throughout the summer to research. Like I said, these are not research projects that are like coursework where we know the outcomes. These are, you are paired with faculty that have existing external funding for particular projects. You are immersed in their lab as a core researcher. You are expected to kind of independently think on things and have ideas at group meetings and things like that. This can feel intimidating at the start, but every student is kind of placed in a lab where they're not by themselves. They are surrounded with graduate student mentors that they're interacting with and communicating with and discussing topics on a daily basis. So, they're not really thrown in. I mean, they're thrown in the sense that you are in that lab now, but you're not let go immediately. You will be trained on techniques. You'll be trained on really high-end instrumentation, stuff that you wouldn't be getting in your lab courses. And most importantly, this last bullet, right? You really get to experience the daily life as a graduate student. I was one of these people that really didn't have a laid out plan of what I wanted to do in life. And I had no plans for graduate school. I was one of those first generation college students and I had no idea what graduate school really even was until I was nearing graduation. And the chair kind of asked if I would consider graduate school. And I kind of just did it on a whim because that kind of sounded fun at the time, but I had no idea what that was going to be like and what that really entailed. So kind of giving these students this experience on this is what this actually is, I think is incredibly valuable. You can look, so these are a couple, at the close of our program each year, we have an external evaluator. It gives a lot and what a lot of people say is, there's this idea of there's a lot of failure and waiting, and it's kind of this real world experience. Like I said, it's not cookie cutter labs. There are days of frustration and you're not understanding why something works and going back and reviewing notes and trying to come up with ideas on how to make it better. That's really what research is. And I feel like that's something that a lot of coursework tries to get apart or kind of tries to get across. But until you're in a research kind of environment, I feel like that doesn't really come to light. So I feel like that is just kind of hugely important. Other types of kind of professional development we do. So the other kind of 20% of your time in most REU programs is going to be sprinkled with different workshops and seminars and other things like that. And like I said, any of these seminars and workshops in these REU programs are all still focused on that central goal of increasing diversity in STEM graduate programs and ultimately STEM careers. So they're all kind of focused, like I said, on really building students' confidence and kind of preparedness to transition into these kind of this next stage of their life and careers. With respect to kind of research skills and overall communication, we have different workshops on things like how to write an abstract, how to effectively present data, how to create a research poster, right? And hopefully in a lot of your lab classes, you've, highlighted some of that stuff, how to, create a data table, how to write an abstract, but actually putting together a full, research poster and kind of, figuring out, the best typograph or best mechanism to really, showcase this kind of new data that you've developed. And then also in terms of that, we have weekly student seminar series. So each week, 2 students will present their research to the broader audience. So to really all of their peers, and lots of times different student mentors will come as well. But the idea here is kind of just building confidence in your ability to really communicate your science and to talk effectively, not only from people in your research lab that know already what your research is about, but to students that are working in these other research labs that have no idea what your research is about, right? For you explaining your chemistry to the engineering student in the room, right? It's kind of fostering your ability and confidence and really being able to both present technically and in a lay fashion as well. The other thing I feel like it does a really good job of is because most of these REU sites are so multidisciplinary, it really kind of showcases the breadth of a focus area and what all you can do within that area. You know, like for this program, for example, we have applications that range from, you know, creating a battery catalyst all the way to creating a breath sensor for COVID. So stuff varies in such a huge way. And I think it's neat when students can realize that, you know, their expertise in one area can be utilized in so many different fashions. And then this all kind of builds up to a closing research symposium. And I think you would see this really in any REU site. This would be something, this kind of closing event where they've created their research poster or their presentation, and they're going to present it to a really wide audience. Normally, these are open to all of campus. The other thing that's nice about these two is most REU programs, as I mentioned, are providing some sort of post-program support as well. So now students also leave with this research presentation in hand. If they want to go experience a national conference, if they want to, you know, go to a regional talk, they kind of have this at their disposal. So even after they leave and their research has come to a close for the summer, hopefully they still continue seeing the impact, and hopefully this is still continuing to kind of build excitement within them. All right, and then a couple other things. So in terms of, kind of understanding career pathways, like I mentioned, we'll have different seminar series from both faculty and industry professionals to kind of highlight these two pathways, things to consider. These are kind of open discussion questions where students can kind of just openly ask questions they're considering, you know? I feel like ultimately, often these two types of careers have different pathways. You know, for example, if you're going into academia, you know, normally, you know, multiple postdocs and things like that may be much more common than if you go to industry. So it's nice to talk with these people that are in these fields and talk about, you know, what type of people they hire, what are their, you know, experience expectations, things of that nature. And normally this is coupled with things like industry field trips and stuff. So the students here get tons of, you know, information on what academic life is like because they have full 10 weeks here. But we try to also get them out of that academic setting and more into some industry labs too, where they can kind of at least kind of gauge what that's all about as well. And then in terms of graduate student planning, like I said, we do a lot of work on that as well with a couple things, right? So we'll have a workshop normally on how to find and apply to graduate programs. And then this last one, this kind of second one is normally one that's really well received. We typically have kind of a open discussion panel with graduate students. And really, even if you don't participate in an REU, if you're even vaguely interested in graduate school, I feel like this is something you should be doing really anyway. So this is something where we don't invite mentors to or faculty, and students can openly ask anything in terms of how many hours do you work, you know, what do you get paid, things like that. And that kind of highlights another thing we talk about too in terms of finding graduate programs. You know, there's a lot of people that have this kind of, you know, idea in their head that any type of more schooling is just going to cost more and more money. One thing we noticed early on with a lot of this REU data is we would ask questions when they were leaving in terms of what do you plan to do next? And we noticed that a huge amount of students were all planning on getting a job in industry and then hoping that job in industry paid for the graduate school. Not even realizing that a lot of graduate programs kind of offer TA-ships and other ways to kind of be paid as you go in school. So, you know, again, it's this whole idea of kind of hopefully recruiting a lot of students that may just not be aware of these things and really kind of foster this mentality that they can do this. You know, here's another kind of quote we got in recent years, which talks, you know, this was a student from Ivy Tech that, you know, never had in mind that graduate school was even an option, you know. All right, in terms of finding these REU programs, if this sounds like something you may be interested in, like I said, we have several at IUPUI. We have ours in nanomaterials. I think we also have one in computer science. But don't stop there because all of these programs, for the most part, are going to provide travel costs and lodging. So you can really go to different parts of the country. So choose really a topic that is just really of interest to you. If you go to the NSF website, really just if you Google NSF REU sites, you'll very easily find a search tool on the NSF page for these. And you can just do a keyword search on something of interest. So for this, I did a nanomaterials keyword search, and here is our program right here. and you will see a link to that program. When you go to that link, it will take you to that specific school program. So one thing that's important in terms of applying is that these application materials are not reviewed by NSF. NSF gets funding to get these sites going, but then these sites are fully managed really by themselves. So you will be directed to that school site for that particular REU. And each REU application is going to be different because that's totally at the discretion of the REU team. But kind of some basic materials to consider, right? Normally would always ask for your home university. And this is nice because like I said, this kind of also tells researchers, you know, is the student coming from a school that maybe has some more limited research offerings? Summer address, that's kind of a nice thing as well. You don't think about this, but so for example, we typically, in terms of what we can afford, kind of like the number of students we can recruit, we normally try to pull like half of our students from a national level and like half locally. And so this is kind of nice because a lot of students may go to school somewhere else, right? But may kind of live in a different town in the summer. So you can take advantage of that. The other thing, almost everything will ask for major and GPA. And I know there's been talks of GPA values and some of the other talks as well. I will tell you that in general, the GPA of most applicants is 3.5 or higher normally. That would be an average. However, I really don't use that as a deterrent. If you're interested in research, you know, we've hired students even in like the really less than a 3 before, but they've had kind of glowing essay comments on, you know, why they're interested in this. And they've had letters of support from people that have said, you know, hey, this, you know, he had maybe had a rough time in this part of the course, but really excelled later on. So really you can save yourself with a lot of this thing. You know, I think it was the first person really talked about, you know, finding the right people to write your recommendation letters. And this is a game changer with really all of these things. Again, you'll probably be asked your current state and expiration, or sorry, your expected graduation date, right? Kind of like I said, while we do hire a lot of senior students every now and then, really the goal is to get students interested earlier on. And then obviously, since the goal of most NSF programs is diversity, there'll probably be some diversity indicators as well. But the good thing is you can see there's a whole bunch, and what they're calling diversity is not just race, ethnicity, gender, right? It's also first-time college students. It's also coming from limited universities. It's kind of full, you know, diversity over this big range. The other materials you'll probably, you know, the last things would be like questionnaire materials. This would be more of the stuff that you would provide, right? One thing would be resume, obviously. And then the support letters, like what we talked about. In essay comments as well, but I kind of want to highlight these kind of red bullets at the bottom, right? Because I think we've kind of had to encourage students to apply for a lot of this stuff before, because they think, you know, I'll never get in if I don't have past research experience, or, you know, I don't really necessarily plan to go to graduate school, so why should I do this? And these aren't really deterrents for this. In fact, these are things that I kind of like to see in a lot of these essay things. If you're on the kind of the edge in deciding if graduate school is even right for you, really, I'm super interested in recruiting you then to help you make that decision. So, you know, some of the other speakers today really talked about personalizing your kind of questions, and that's kind of ways to do that, right? So, you know, tell me, you know, why you're interested in this. Is it to see if you like academic research? Is it because you really, really love the particular focus area the site's interested in? Don't just give me general things like, I want to gain research experience. Those things immediately go to the bottom of my stack. I want to know something personalized about you, what you hope to get out of this. That's what I want to see, right? And then hopefully your support letters are backing that up, right? And the other thing, again, if you don't have research experience, no problem. You can get support letters from, maybe you have like a lab course and you can get a support letter from that faculty. You know, I would expect at least a couple of support letters from more academic, but if you want to give me a letter from your employer that talks about your work ethic, that's no problem either. So yeah. But then the other thing to note is these are super competitive programs. So like I said, GPA, we can work with that. A lot of that stuff we can work with. What I mean by competitive is that each site receives a ton of applications each year. Ours alone normally averages between 200 to 400 applications each year. So the important thing is really don't limit yourself by applying to just one site. So like I said, there are hundreds of these in tons of different areas. And like I said, even if it's in an engineering department, that's not to say that they won't hire someone in chemistry. So if it is a focused area that interests you, I would encourage you to apply to that. And the other thing is, I would really encourage you to apply to places outside of your home institution, right? So when we talked about all of that stuff earlier on, a huge goal in this is really finding students from colleges and universities that really don't have the chance to do this. So, hey, if I have an REU at my site already, then we have research happening and you have a chance to do this and get involved. So I would really encourage you to apply to kind of, it doesn't mean if your comfort zone is in the state, you know, fine, you can find other areas, but I would try to encourage you to apply outside of your home institution. And then just because the number of applications, I would get them in early. So while you think in your head it's a summer program, I have the bulk of my applications submitted and in by January, and we're already starting going through them as early as February. All right, so just some kind of general key benefits, and then I'll give it to my next speaker on why you might want to participate in an REU site, right? I think I've beaten into you at this point. It gives you an understanding of what graduate school and research is. Huge benefit. I feel like that really helps you kind of figure out what your interests are and what you want your kind of next step to be. But the other thing, right, this is a competitive program as well. This would look great on a CV. You know, in terms of a summer job, most of them are paying around $6,000 for 10 weeks of research. But like I said, they expect you to have no other job. This is your job for that summer. And I really think it's just kind of building these skills that you will use throughout your careers in STEM, whether that involves graduate school or not. And then beyond that, in terms of post-camp program, like I said, we're hoping that you kind of connect with this faculty mentor and you kind of end up with this kind of lifelong mentor that you continue asking questions to. And kind of really building kind of networks of peers and other faculty and industry professionals, all within an area that you're really of interest in. So while the professional development, while the research focus and context of all of these different REU sites will vary, really the central goal of all of these things is they will all provide this actual kind of hands-on, throw you into a lab, academic experience, in their own kind of collection on different tools and seminars and workshops to really promote your interest in graduate school. So with that, I'm going to pass the mic over to Mark Wilhelm, who is a graduate student in our lab, who has participated as a kind of REU mentor for these students for a couple years now. He can kind of comment on what kind of stuff they normally
phone. So I don't have the slides on my phone, but I'll just give you a breakdown of what I've seen. I've mentored 4 REU students, and they've gained so many skills. One particular REU student, he actually, after his REU experience, he came to IUPUI to, do academics and continue his research because he just gained so much from it, and he wanted to continue. And, he went on to perform amazing research, amazing multidisciplinary research, where he worked directly with biomedical engineers, mechanical engineers. And he actually gave a poster presentation at the REU presentation session and at an ACS undergraduate conference. And he won a first place poster award. And in the spring of this last spring of 2021, he actually just got his first publication based on the same research. So he really gained writing skills there. Like at the beginning when he was first starting to write the papers and stuff, it was, a really long process. But now, we're writing more papers and he's writing awesome. And it's really cool to see the growth of these students. And I have no doubt in my mind when he applies to graduate school, he's not going to have as many problems. Or, he's going to be more confident in his abilities. And overall, lastly, not only will you have the publication skills, but really the communication skills really the communication skills as Dr. Menner previously touched on, communicating not only to scientists in your field at a technical level, but also explaining to other scientists in different fields and in a lay manner what you do. Sorry for that, guys. This was unexpected and unplanned, but I would like to introduce our last speaker, Paula Angarita Rivera.
We're trying to connect once again. Let me try one more time, and if not, we can go over the phone.
Sure. In the meantime, Mark, maybe you are able to answer a question when you're trying to determine, what kind of research you want to do, what kind of fields you want to go into. What would you recommend as a good starting step to start making that kind of a decision?
Yeah, that's a great question, and it's a really hard question when you don't know what to do. The first step is just doing some research, online, and just reading different fields, different papers, or maybe even like a step below, not as technical, but just looking at different research, and then something may pique your interest. But at the end of the day, to really know if you're interested in this field, you're going to have to go and try to get some experience in it, hands-on.
On the toe.
Yeah.
The other thing I would say too is what's nice about these REU experiences, right? Is maybe you pick a content area that you think you're really going to love, and it turns out that really you've decided that's not for you, right? But you're really working alongside of these colleagues and peers that are working on these other projects, and maybe you realize, wow, I really love what this guy's doing, and maybe that helps kind of spark interest as well. So yeah, kind of what Mark says, it's hard to know if you're going to like something before you do it.
Great. Right. Hi, everyone. My name is Paula Angarita Rivera. I am talking on behalf of the nanotechnology. I work with Dr. Mangilar Agarwal. So I am very thankful for the REU program in general, because it opened my eyes to an area that I personally see that there's no representation of Latina female people. So when it was given to me the opportunity to be part of it, I knew, well, I could be one, right? And I can start bringing opening the path for future Latina or Latino female or men who would like to be in the research area. So this happened in 2017. In 2017, I had my first experience working with Dr. Mangilar Agarwal in the project that relates to creating a breathalyzer to detect hypoglycemia from breath, correct? I had no experience. I was coming from a college where we have very limited science or STEM research due that is a small private college. So when I had the opportunity to just come to IUPUI and see all the research lab, like engineering labs, chemistry labs, I think that's when I opened my eyes that engineering did research. I don't think I understood that until I got into actually being in a lab with engineers. And then I realized that my lab was so diverse, right? I was doing biomedical engineering by then, but then I was working with chemists, I was working with electrical engineers, I was working with mechanical engineers, and I was like, wow, like we all complement each other. So as Dan said, sometimes I felt like, well, I have nothing to say here, but my perspective, it brings a different area where they think more of like, well, if you are coming from a different background, how our research is addressing that. It's not just addressing what is the common, but what is not being taught. So I learned so much that Dr. Agarwal invited me to join his lab due that it was in the same city. I've been working with him for 4 years now. And in 2018, I decided to join again REU. And I met incredible people. Let me see if I can like flip the camera and show you kind of like the cohort that we have. Well, no, like this. The cohort that we have, it was very diverse. Here is Dr. Agarwal. And then here are some pictures of one of the things that I really like is that Dr. Agarwal also, at the same time of REU, he has a program for high schoolers. So I was able to mentor high schoolers, even though when I've been mentored by graduate students. So it's kind of like you just like transfer all your knowledge from like graduate to undergrad to high schoolers. You don't stay with it. I was exposure to clinical trials, which is like going to the field, collecting samples, being able to recruit patients. And then after in 2019, when I finished my undergrad, I was offered a master's degree, fully paid. And then the reason why I was fully paid is because I had all this knowledge gained because of the REU program and like working in the lab, that for the professor, it's better to keep you because you already know so much about it than like bringing someone new. So it's definitely very worth it starting learning research at your early career. There are so many times that you are not gonna know, but that's the reason why you can ask questions, always ask everything, and always take advantage of your mentors because they were in your position many years ago. So they know what it is to be a learner. And then let me show you one last one. I was able to attend to my first international conference, which it was with the Society of Mechanical Engineers. Then I went to the Emerging Researchers National Conference, which is also sponsored by NSF. And I received my first place in a poster presentation. And then I went to SAGNAS, which is Society for Advancement of Chicanos, Hispanics, and Native Americans. And I received my soccer initiative scholarship. They pretty much paid for my entire trip just because of how good my research was. So sorry, I know I had to talk really fast. But do REU, highly recommend it.
Thank you so much. That was wonderful. I really appreciate you guys being able to stop in. We give a virtual applause to our speakers today. That concludes the first part of the sessions of today. Please feel free to go search through the Wahoo app, do the surveys, and then we'll take a short 10-minute break and you guys can go ahead and log into the next sessions. It looks like keys to successfully navigating a career in industry or some international affairs roundtables and workshops. So thank you all for tuning in this morning and we hope to see you again in a few minutes.